Alright, let's go. Let me delete a video real quick. Cool. Alright, hour and a half-ish. What is this? Is this any good? This seems like good. What is this? The voice is kind of boring. Some Vocaloid stuff, not a real voice. Oh, bro, this delay is so terrible. So boring. Give me real music real quick. I've been craving music for learning recently. Seems cool. Oh my god, this delay. It's never useful. Yeah, this seems good. Okay, let's go. So const expression, like right now, I know that there are... I can make a const expression variable. And this guy will be evaluated at compile time. So right now with value 0, but let's say it's with some big ass integer value, like 2 million something. Or 20 million? Yeah, 25 mil. So at compile time, when this is compiled, I believe what happens is it automatically does constant or value substitution. So it would just swap this to be whatever, 25432, whatever the fuck the other the numbers were. And it would swap that to be, or it would substitute that anywhere it's used. That way we don't have to store anything in memory. We just put this value there. So I guess the code is like an instruction manual, and sometimes it says, hey, you need a container to store some shit and keep it in there throughout the instructions. But maybe instead of that, we can say, hey, just put, like, instead of saying, hey, store some number of nails here, instead, it'll just say where, like, it's hard to say. It's like storing a value versus just using it literally. Because in real life, if something physical has to be stored somewhere, I guess it's like having the nails, and instead of me having to store them somewhere, I just put them where they're needed already. So if I'm doing step 1, step 2, step 3, and each one needs 2 nails, instead of me having 6 over here and then using that bucket to store them, I can just put 2 over there for step 1, 2 over there for step 2, 2 over there for step 3, and I don't have to keep track of them. Meaning, so like if we have, we have 5 here. And then I do a bunch of shit to 5. So we have another variable. And it's initialized to be 5. And then we're going to... Excuse me, what else am I going to do? Something like this. I have other variables that are initialized using this first one. I mean, sure, I guess rest isn't technically used. But best is. What are you saying? Oh, oops. Well, yeah, I guess best isn't being used either, so that's fine. Okay, whatever. So we have a variable here. Instead, if I make this guy const expression, if I make him const, then the compiler might do what I'm about to say. But if we make it const expression, it will, I think, do this, where it will just have 5. And we don't need to store it anywhere. It's just going to replace it. We don't need an instantiation. We don't need a piece of memory dedicated to holding 5. We just replace 5 everywhere 5 is used. And then boom. It's faster. We don't have to look at some place in memory to get the value every single time we use it. We just say, hey, it's 5. It's just, it is 5. That's it. It's kind of hard to explain, but basically the compiler can optimize shit away. That way, we don't have to, at runtime, open up a little space in memory or find a space in memory, find a parking spot and park 5 there. And then go and find that parking spot to use it every single time we want to use it. Go and find it, use it, go and find it, use it, go and find it, use it. Instead, we can just put the car exactly where we need it. And we don't actually even have to do that. The car's just already there. It's like James Bond coming out of a building. The car is there. He doesn't have to go and find it and then put it there. It's just there. And then he goes over here. It's just there. We don't have to store it. We don't have to do anything. It's more optimal. And some functionality needs a const expression value, a const expression value. Bro, what is happening here? there's like skin. Never mind. I think it's just a booger. Yeah, probably. Who cares? What are some things that need const expression values? I mean, maybe I want to check something that's constant and unchanging and optimal. Maybe we have like a because const expression stuff also isn't anything. I don't know if we can have a const expression class. I think only certain things can be. Like, can we have a const expression standard string? I don't remember. Whatever, I don't need this. We'll just do... and then we'll just do... Yeah, it doesn't evaluate to a constant, but we can do it for floating point values. We can do it for integral values. Seems like we do it just to optimize things, to make things known at compile time. And things that operate on compile time stuff, like we can't use const expression parameters in a function, but anything that requires compile time stuff, like static assert, for example, this guy here needs compile time values. What else? I guess that's kind of it. Seems like it's mainly for optimization. And I mean, it's also just another way of making something constant and optimal. So instead of having like a namespace and constant variables that are stored in memory, maybe we can avoid storing them in memory, but we can still reference them. The code will just, the compiler will just do the substitution. So like later on, if I'm calling a namespace to get a const expression variable, oh, actually, that's not how that would work. It would be, const expression variables have to be, am I good? There's like, it feels like a skin in my nose, but it's not. I think it's just a booger. Inline const expression variables that we use in different files need to be inline defined. That way we can use one little, I guess the point is that we can use the variable. Well, I guess it doesn't really matter if const expression variables are inline or not. Because if I have 10 different files and each one of them uses this const expression variable from a header file, so we include the header file into each one. Well, const expression variables, or const variables, same thing, they have internal linkage. So the linker will not look and say, hey, you're using the same variable in this file and this file. It doesn't give a fuck. It doesn't look at it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 copies, and you would think, oh shit, that's 10 different places of memory, 10 different parking spots that we're using. Well, if const expression variables are known at compile time, and the compiler, during compilation, yields a translation unit that replaces the instantiations of the variable with instead, or actually removes them, and substitutes references to that variable with the literal value, then it doesn't matter because that value isn't anywhere in memory. It's just in the instructions. I think that's how that works. So maybe making it inline doesn't matter, but maybe that's not all the case. Maybe I operate under the assumption that it doesn't go through that level. Because if it does, it seems like there's no reason to do inline const expression variables. Because the point is to consolidate the call so that, oh, if we're using 10 parking spots, it'd be cooler if we could say, hey, Mr. Linker, these guys are inline, so look at them, and then use one parking spot. Because it's the same value. Identical definitions are required for inline shit. And if it's a const expression variable in a namespace, we want it to be the same value. So, use one parking spot for it. But if there actually isn't even a parking spot needed, then it doesn't make sense to do inline because there aren't any parking spots. There's nothing to consolidate. We have const expression keyword to make compile time constants, symbolic constants, meaning like an identifier constant. And constant expressions are evaluated at compile time. So like static assert, we could do a static assert and it would evaluate its operand? What do we call it? It's argument, I guess. It's the shit that, well, oh, I guess it's its condition because it's evaluating whether it's true or false. And if it's false, it doesn't compile. If it's true, it does compile. So, but it needs to operate, or it needs to evaluate constant values, values that are known at compile time, because it needs to prevent compilation if their result is false. Okay. Is that Is this worded weird? It seems like it. One challenge with constant expressions is that function calls, or a function call to a normal function is not allowed in a constant expression. Oh, this should just say function calls. Meaning, or in the constant expression? Yeah, because if we say there's a constant expression variable, and I'm like, let's say it's an integer, and I have a function called getInteger, or getInt, and I call that, and that result is what initializes the value. Well, we can't do that because I haven't ran the fucking function because it's a runtime function. So the point here is that maybe we can get runtime functions or compile time functions. I don't think I've touched these at all really, or I've forgotten, but I don't think we've touched them. My sleep is golden now, so I can actually do stuff. And starting in tomorrow and Sunday, or at least tomorrow, I'm going to test out waking up, giving myself an hour from waking up, so like from 7 till 8 to do whatever. And then I'm going to have my alarm going all the time. So an hour and a half of study, an hour of screw around, an hour and a half of study, hour rest, hour and a half of study, hour rest, hour and a half of study, hour rest, hour and a half, hour and a half, hour and a half, hour and a half, hour bed. Because that should be like 16 hours ish. Because it's hour and a half hour, that's 2.5 hours, right? So I can fit 4 of those plus 2. So, okay, I guess maybe I was too much. But, no, yeah, so there's like five of those in total. Or 6? No, because I'm only awake 16 hours, not 18. Okay, yeah, so there's basically 5, a little more than 5. Maybe it actually is 6. Yeah, it is, because 2.5, right? 2.5 times 5 is, what is this? Alright, yeah, we're good. Wait, that's not an, 6 times 6, not times 5. That's only 12.5, right? But times 6 is 12, and then 6.5. Yeah, 15. Oh, yeah. And the hour. Yeah, I get six things. 6 study plus whatever. And that's 6 times an hour and a half of studying. Oh, that's a lot. Is it 7.5, 8 hours? Hold on. Yeah, 8.5 hours? Hold on. 9. Wow, I'm stupid right now. Okay. And so if we had a const expression function, what would it be used for? It would evaluate and do stuff at compile time. And the point is that we could initialize things with it and maybe have some cool logic going on at compile time. But only some things could be done at compile time. Like, I don't think we could do standard character output at compile time because it's not going to run, so it's not going to actually do it. Yeah, and if a const expression function is one that is called at compile time, then yeah, that'd be interesting. Oh, I gotta go to the bathroom. Ah, fuck, do I pause? I'll just be right back. Damn. Jesus Christ. Excuse me, that was way too slow. Excuse me. Oh, it wasn't even too bad. 2 minutes for a poopathon. All right, let's go. Meaning that we can't initialize this shit with function calls. Consider this program. Ow! Fuck my shoulder, dude. Just have to keep using it. Through the pain. For mobility. Ow! Fuck. Oh, it hurts. Holy cow. Alright. We have radius 3.0. 3.15159. That's all I know. Circumference. 2 times that. And we're outputting circumference. Okay. So it's 2 times radius times that. Okie doke. Having a complex initializer for circumference isn't great. Oh, meaning just what? Like get circumference? So we're multiplying, yeah, just 2 pi r. I mean, maybe that's kind of crazy. I mean, you could have the regular. Oh, well, you'd probably want your radius to be changeable, but pi can just be. Well, chi's const expression. Wait, they're both const expression? I mean, that's fine. Or you could say get circumference and then just pass it with the radiuses, unless you need the radius later on. But it seems like maybe we. Well, there's no way to know. Yeah, and in this case, we're just passing it, so we don't have radius, but we could store radius somewhere. Okie dokus. Oh, but the problem here is that we're initializing a const expression double radius, or hold on, double circumference, with calculate circumference. And it's a complex initializer. Why? Because it isn't. Because it's something with operands or multiple operators, maybe, or that it has any operators. Yeah, instead of doing that with pi, we could just have pi somewhere else, and then we're cool. But then we're also assigning this value every time. You may as well almost make it. I mean, you could make it static, but then it's just memory you're taking up. So I guess it's not so bad. I mean, I would rather just store pi somewhere else. That way, every time you call it, you don't have to give it pi. Okay. But is it better to assign value to pi, use it, and then unassign? Or is it better to assign it and then keep it in memory somewhere else as like a global variable? I don't know. Maybe it's better. I guess it's better to have it in the smallest scope possible. So I'll just assume that these processes are very small. Just trying to consider these things. That way I have a good framework when I'm developing stuff and I'm making it in an efficient way. I think too many companies push out products that aren't optimized enough. I think you need to start from whatever the most optimal thing is. Or I guess get a viable product and then cut that shit down. But ideally, the viable product is already made with a framework of optimization. Just like, I don't know, if you were going to buy stuff and you were going to give everybody a $10 tip, sure, you would get the food by the end of the day, but you'd have paid a lot more money. If you had started with a more frugal approach, maybe a minimal tip or tipping only when it's appropriate and giving a tip that is fair, then you'd be even more efficient. You'd be getting your food and also having as much money as possible left over that's fair without being a bitch ass. Okie doke. So in this case, we're calling const expression, or we're initializing const expression double circumference in main with the return value of calc circumference, passing it this double radius 3.0. And then we're returning. The problem here, though, is that this does not evaluate to a constant. Why? Because we can't call calc circumference at compile time. This is evaluated at compile time, and this can't be evaluated at compile time. Yeah, the initializer must be a const expression. Yep. And that is not a const expression. We could make it non-const expression. Yeah. Exactly. I mean, if the point is to have all the shit run at runtime, or at compile time, sorry, because then technically you could say that, hey, circumference would actually just be this, and then the value would just be substituted everywhere. So circumference would just be whatever the result is here. So 3 times that, it's like 18-ish, a little more, maybe 19 something, 19.5. Yeah, the whole point here is to have an unchangeable compile time value. Ow. Where we don't have alternate option. Yeah, so meaning in this case we have an alternate option, which is just take out the const expression. But in some cases, whatever feature it is in C++, it needs a const expression. Why? Maybe we're passing a non-type template parameter to a template function, or to a function template, because it's something that needs a const expression value. Like the number of bits for a bit set is needed at compile time. We can't decide that at runtime. Therefore, if I still want to calculate the number of bits, like maybe on this architecture we do 4 bits, on this architecture we do 8 bits because whatever, size limitations or something like that, or efficiency maybe. So on this architecture we can have a const expression function that calculates the number of bits needed, or we just have one and it checks depending on the architecture and returns a const expression value that we can use to then do the right number of bits in the optimal way. But we would need a function that is run executable at const expression or at compile time. Man, this is a fucking bop and a half. Holy shit. Take my like, dude. Oh, good ratio. 200 to 1 likes to dislike. Yeah, more than that. Wow, good job. Like 2.2. That we really want to use a function, but normal don't work. Const expression functions. So how does that work? Can I just do that for the return type? And then it just has to operate using const expression stuff? I'm curious what happens if we do standard character output. Can it just not use const expression or non-const expression values? I'm not sure. Or non-compile time values? Number of days in a year, and we want something at compile time to say, hey, what planet are we on? This is the number of days. Cool. Num days. Get num days. Oh shit! That's it. We took this out. Not a compile, not a constant. It's not a compiled time value. It's not known. It's not const expression. Okay. So we can have like what about conditions and stuff? So like if we said, what if we initialize some variables in here? Oh, it's actually okay, maybe? I wonder how that works. It evaluates and returns. So maybe it's okay that it runs. It's just not, we can't do standard character input though, maybe? I'm curious. Okay, let's do, Really? Excuse me. So it's able to evaluate this condition at compile time. How about some string action? So we could say cool. What about oh, I think I've seen it. It still has an issue here. Oh, so what if I remove that? We're cool, and then I add that. We're not cool. So yeah, the call is getting fucked up by this. And then what if we also had, what if we say in this condition, then we have, excuse me. Oh wait, hold on, oops. Wait, we can actually do standard character input dot get line? Really interesting. Still, okay, cool. But if we remove that, it's cool, it's just not used. But it doesn't care that it's not used because it's not an integral or like a built-in type. And what we would be doing here is getting the entire line for the string. So that way, if we're doing multiple words, we're cool. Otherwise, we could just do standard character input, I think. And it also ignores any leading white spaces. So if we had done a number before and then pressed enter, or extracted an integer before and pressed enter, well, there's a white space in the buffer still, and it only gets killed once we extract something else. So in this case, it would ignore the leading white space, but then leave them in the extraction here. Okay. So it seems like there are some things that only operate at runtime, and it seems like standard character output and standard character input, so input insertion and extraction, are only doable at runtime, not compile time. April, May, June. So yeah, I'm about 3 months into C++ now. Cool. Plus or minus 2 weeks. Well, probably minus 2 weeks, but. Yeah, we simply use the keyword in front. Okay, seems like that makes sense. Yeah, yeah. The function is used in a const expression. It's probably going to say that there's some sort of limitation somewhere that limits the shit that we're able to do. Why exactly we can't do standard character output? Is it because the side effect isn't doable? I mean, it's not affecting the result, so I'm not sure why it says the result did not evaluate to a constant. Maybe it's aborting somehow if it's const expression and we're doing it. Therefore, it's not returning the value that we expect. And I can only debug at like with the debugger at runtime, so I can't exactly check where it's getting held up. This is a comfortable ass way of sitting. I just need like, what if I sat with a pillow behind me? Would that be even better? Maybe. Curious. I found the most comfortable way to sit and program, at least. Yo, headset? Oh, this is kind of good. And, oh, wait a minute. It's pretty good. That's interesting. I don't know. I can't sit as far back though, so it's not like if I sat more forward, I can't lean back as much. So maybe I'll undo it a little. Feels pretty good. Okay. Oh, so like in this case, we could do. Don't need this. That's all I know. Maybe I have to put const here for it to be okay. Is that what's happening here? Oh, hold on. Oh, oops. Nope. Oh, well, hold on. Oh, it's actually okay here. Oh, oops, that's also true. All right, fuck it, make it all double. Okay, so it's fine. So it's a weird thing, but it's interesting. So a const expression function returns a const expression value, but that return value, which is a temporary object, so the function gets some sort of value at the end, assigns that to some sort of temporary const expression object in this case, which then is assigned to be whatever the hell we're initializing with it. In this case, circumference. So even though we're multiplying it by a non-constant, radius actually is const in this case. What if we said, oops. Cool. Okay, that makes sense. So radius was 3.0. So it's actually okay that this doesn't say const or anything. I mean, sure, it could say const. All that would mean is that in here, oops. Even though it's not changing anything, we can't assign anything to it because it's const. That's all that changes. All that it matters. We just can't change radius in here. I mean, we may as well make it const because we can't change the radius, so it's fine. But the compiler will say, hey, it's a const expression value. We're cool. This guy is operating using const expression values. Therefore, this is only using const expression values. It's not some runtime bullshit because int radius is only put into memory. It's instantiated at runtime. Therefore, if we're multiplying a runtime value by a const expression value, well, to get a const expression value out of it, Nothing can be runtime because that shit's not known. It's like having this times this plus this, but this part isn't known until later. Well, I can't give you an answer now if I don't have this piece until later. Cool. Cool. So we can do a cost expression calc circumference. This band is really good here. I want more of that. This is embalming. Embalming's pretty good. What else though? I listen to like everything this guy's got. Scuba? Shabba dabba. Shabba dabba. Alright, I'm gonna do a couple push-ups real quick. It's gonna be hot though. Yeah, fuck it. Just have to make sure the pillow doesn't fall out of the fucking chair. Okay. Let's do, or well, fuck it. I'll put the can down. A little ego action. It's fun. Alright, hold on. We'll start left. Got to use the shoulder to fix it. Still have no idea what happened to it, but oh shit, these lyrics are good. Okay. Yep, it compiles now because it's being initialized with a const expression value. It's the entire point here. That's meta. Makes sense. Which means we can't do some things in it, seems like. Oh, I'm sitting kind of low now. I guess you can't even see me, maybe. Yep. 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 Cool. Okay, yeah. So, in that case, it's replacing the return value with the result, with the return value. And if that's the same, if that's the case for, like in this case, circumference, after compilation, we just see 18.85 or whatever the result is. We don't see anything else. We don't, at runtime, we don't see any calls. Oh, that's kind of interesting. So if I run that, then I shouldn't even see a call to the const expression function, right? Because it's not run at runtime. Is that right? That's kind of cool. If that's true. I mean, it seems like it'd be true. Can't do a standard string here, so whatever. We'll just... Yeah, sure. We'll do that. Yo? Motherfucker, I keep doing ints. Oh my god. Oh! Because it's already known. Nothing? Garbage value. Or, well, right now in memory there's a garbage value. Well, I guess it's reading that, but then after not going into any calls, it's just getting the value. So it seems like the debugger is saying what was at gravity, but doesn't that mean... So it seems like gravity does exist in memory, and that's why we use inline const expression variables. Okay. Or, well, how about we do this? Yeah? Hello? Yeah, the call was already done. So I guess it's saying at program start, there was nothing in this piece of memory, but this value was already done somewhere, and now we've initialized it. So I guess it's saying, hey, there's a bucket here. By the way, we already have this calculated value. Let's put it there. Something like that. That way we don't actually see the call because the call's done. So you could maybe have some complex shit, but it's done at compile time to get the value. Maybe that's how shaders are? Like we have to figure out the values of a fucking trillion numbers on program start. Maybe instead of making your program file 50 gigs bigger, you just say, hey, load that shit at compile time every time. Honestly, I'd rather have that shit just written somewhere. Like, I'd rather have a massive thing of storage behind me instead of adding 30 minutes to my fucking startup time for a game. Because it wouldn't be massive storage, it'd be a fucking hard drive. It'd be or a solid state drive. Bro, this little tiny USB drive I have is 256 gigs on my keychain. It's super tiny. So, even if it was an extra terabyte of space, okay, bro, it already exists. We don't have to rewrite that shit every time. I mean, it's just like, I don't know, paying down your house. Like, I'd rather just pay down the house and I own the shit instead of paying every month and having to pay twice. Because every time I run the game, I have to write memory and create this code or create these values and determine them. I'd rather just determine them once and save them. They're good. And then sure, there's an update. Okay, let's compile shaders at fucking midnight on my computer while I'm sleeping or something. Or just whenever I turn the computer on, it compiles my shaders. Well, yeah, that kind of makes sense because that's what they say. They say compiling shaders. Seems like there's some infinite number of angles and whatnot, and when the shadows should be drawn, and when how the color should change, and all that shit. Maybe it has to be at runtime, though. I don't know. It says compiling, so that would be a misnomer. Yep. Function calls replaced with the return value because it's already run at compile time. Even better ratio here. Wow, nice. Yep, exactly. There it is. Yeah, the call, we can't, bro, if I'm using these arguments, the arguments have to be known at compile time. I can't pass you a call to a non-const expression function is as an argument to a const expression function because the non-const expression function isn't evaluated at compile time. It's evaluated at runtime. Wow. The body's pretty cool with how easy it is to recognize when something's touching you, even if it's just a little tiny thing like that. Like it's my whole finger's lit up because of that. Like it's so obvious. Even more obvious there. That is insane. Right there. Not so much in the hair, but okay. Yeah, and everything in it must be evaluatable at compile time. So it seems like the operation of standard character or standard character output insertion is not evaluatable at compile time because it's a statement. It evaluates. Well, it's also an expression. It's not just a statement. Man, this is a great one. Where's she at? There she is. Quality? Bump it up. Oh, it's already bumped up. Girl with face stats is actually, it's kind of cool. Any other functions and its calls must be also, yep, exactly. Well, yeah, duh. A thing that has to like, if something happens at a party and you're bringing something to the party, but the thing you're bringing only existed because someone else brought it to the party, and the party has to commence in order for you to bring it to the party, i.e., I'm calling a const expression function, but the const expression function calls a non-const expression function. Bro, we can't go to the party and do something that was required before the party. I can't go to the party and pop a bottle of champagne if nobody brought a bottle of champagne. Hello? Give me. And look at this lady again real quick. Oh, damn. Alright, well, let's do it again. And these moles. Holy moly. The blessing. Alright. Cool. Is this some fucking CPP reference shit? Yeah, it is. Fuck off. Alright, I'll check it still. It is not of class type. Okay, so it seems like we can't do const expression classes. I think that's what that is. Const expression functions can also be evaluated at runtime. Interesting. Meaning, oh well, yeah, I guess it would, wouldn't it? Like if we had a regular function that had a const expression value in it, and I use that const expression value for some reason, like I mean gravity, for example, or pi in that function. If I return a non-const expression value, well, yeah, it seems like the value for the const expression variable, the local variable, wouldn't be known until, well, maybe it would though. I don't know. at runtime. For example, wait, is this cool? Hold on. X and Y, not const expression. We return greater, and greater is a const expression function? I'm surprised it even works. So there's nothing that flags to tell you that it's not going to be executed at compile time? Really? Seems kind of dangerous. Oh, oops. Really? And we can see that it's being called here. It's not just skipping. And that's because testkit is instantiated at runtime because it's not const expression. But if I had changed this to be const expression, then it actually still does go to it. Interesting. What if I made this const? Was I wrong earlier? Maybe I was. So why is it here? Oh wait, I don't know what happened here. Bro, why is it not fucking playing again? What happened to the loop? Oh, I didn't loop it, I just started it from the end. Oh. Oh. So if I call it, I think I figured it out here. Bro, what in the fuck? Yeah, it skips it here. The point is that I was calling getting kids here extra. Hold on. And when I'm explicitly calling it and not... So if I'm just calling it as is and not initializing... So if I'm initializing something with it, it will get the value already and initialize the const expression thing because the const expression thing requires it to be done at compile time. But const expression things don't necessarily need to be done at compile time unless they're required. That's kind of old. Wait, maybe not. And that's the point. So we're calling a function at runtime by just explicitly calling it. The reason it's not called at compile time is because it doesn't need to. If I'm initializing something at const express or at compile time, then with this function, it must be called at compile time. So it seems like it favors calling things at runtime, actually. I guess it just depends. Const expression things are only done at compile time. Is that Thor? They're only done at compile time when they must be. This one's okay. It's not as good. And in this case, standard character output is only run at runtime. This is why. Well, it's for two reasons here. So the function doesn't necessarily... The const expression function only needs to be executed at compile time if it must. I think it's the worst like ratio so far. Bro, what am I fucking doing? I'm not clicking the right thing. Returning the value as a non-const expression int. Interesting. When it evaluates at runtime, it runs like a non-const expression one. Okay. Allowing them so that a single function can be run in both cases. So like we could run, like in my game, I could have a game where I do some shit and it saves the state, and then I change stuff up because time has passed like 10 years later. Like I could have a game release it, and then at the end, after you finish the game, I could save the data, which maybe updates the code with the player data and the world data. And then I change other shit up and I compile it, which runs the shit. But when I actually run the program itself, then those same functions for like attacking another enemy or something, but they're using classes, so maybe that doesn't work because I don't think you can do class shit at compile time. Maybe because classes aren't created at compile time. But then the same functions for attacking offline at compile time execute online at runtime. That's cool. Yeah, that'd be annoying. Oh, also true. Well, unless you added a similar contingency, like for templates and regular overloads, where the call, if it needs to be executed at compile time, so if it's a compile time call or a const expression value that requires a compile time call, then it would call the const expression version. Otherwise, it would call the non-const expression version. Maybe. I mean, I could see how you would make it work, but they didn't do that. Not to mention it would still be a pain. Optimization, baby. It's the main reason, seems like. See how many sections are here. Excuse me. Foreign quiz. Well, and then we don't get another appendix thing for a while. Really at all. Yeah, we don't actually, because that's appendix. Yeah, this is the last letter one. Const expression function calls in non-required const expressions. Yeah, you would think. I think I probably just went over the things that are covered here. Makes sense. It seems like our compiler in this case was choosing to execute those guys at runtime, not compile time. Yep. It seems like every word in Japanese ends in a vowel almost, so it seems like it's really it's easier to rap in that language. I mean, there are only 5 vowel sounds in the world, seems like, so every word can potentially, well, not every word, but like a lot of words can rhyme. Like if gun ends in a vowel in Japanese, you can rhyme gun with other words now compared to in English. You can only rhyme it with other things to end with N. Fun, run, done, ton. Really? Okay. Well, yeah, it's probably easy because it's not required to run at compile time. Like if you initialize it with, or if you pass non-const expression values to a const expression function, the const expression function has to run at runtime. So you'd write it really quick and be like, oh, okay, we're cool. Oh, fuck, those values aren't known till later. And then you have to figure out how do you get the values to run. Like, for example, maybe you have like an enemy perception system. And maybe you're coding stuff into the past about like how some guy fought a dragon and the dragon perceived him. But if the guy's loudness is only determined at runtime, how does the dragon get his loudness to listen and try and get perception? So you have to then make his loudness at compile time, and then you have to do maybe other stuff too. Because then the loudness is created based on his movements in the environment. So now those have to be done at compile time. Those can't be at runtime anymore. Seems like there's a lot of backtracking to make sure things happen properly. A silly example. Okay, so we have int x is calling foo5. Okay. Oh, but foo is probably calling, yeah, non-const expression value. Well, yeah, it makes sense. Okay, cool. Yeah, so x and foo is probably fine, unless it calls some crazy shit. Actually, it's probably fine because the const expression can return a non-const value. And then we have const expression in x that also calls foo5. So if we look at foo to see what happens, okay, it's const expression, so it might return a const expression value depending on what the argument is, or what value the parameter gets from the argument. Okie doke. If it's negative, it returns 0. Otherwise, it returns what it is. So it returns 0 or higher. So it returns basically 0 or greater, basically. So if we call it with const expression value 5, cool. The problem here is, okay, it's returning get value. So we're passing it const expression value, or const expression value 5. Cool. It's not going to return 0. It's going to now call get value, but excuse me. And this is the const expression value because it was const expression, but it's not returning const expression, so it's dropping the const part. Well, so now we've returned a non-const value. We've returned a non-const value. Uh-oh. Cool. Because this guy doesn't need it to be const expression, but this guy needs it to be const expression. So we pass 5. We're cool. Oh, it's greater than 0, not less than. And we call this guy. Oh, it drops the const expression. We're returning a non-const expression value. Not good because it's not evaluating to a constant. Okay, the music is pretty good. I like it. I can listen to music while studying. I'm not losing any focus really either. I mean, sure, I'm not thinking about programming literally right now. Now I am. Yep. Yeah, because the const expression requires its initializer to be evaluatable at compile time. Makes sense. Yeah, call it. Yeah, if you want a const expression function to evaluate at compile time, you must call it in a context that requires it to be evaluatable at compile time, or to be evaluated at compile time. Therefore, initialize the const expression value with its return value. If it's a void returning, well, no, it's not going to be a const expression void function because we don't initialize things with void. So there isn't a context. Unless it's in a const expression function that is required to be called at compile time because it's initializing something, and then you have a void function in there, and it's what happens if you have a const expression void function? Like I'm initializing something, but I need a side effect. Then what happens? Oh shit, you can. Well, yeah, it's not being used by any other file. Think we're good. Let's go, son. So, this is a const expression variable being initialized with a function call, which means the function call must be called at compile time because it's a const expression variable, which its initializer must evaluate at compile time. And the function that must execute at compile time calls another function that's const expression, so it doesn't have to evaluate at compile time, but because this function must evaluate at compile time, well, it has to do thing before it returns, and it must execute at compile time. Therefore, this guy must execute at compile time, even though he doesn't have to. So we could do that, and then we could do thing here. Motherfucker? Okay, I don't like that. It's a dialog box, but whatever. See, this guy didn't have to execute at compile time because there's no context in which he does. And we can't initialize something with do thing, but we can call him in something that does and must evaluate at compile time. Nice. That's proof my brain still works even with music on. Consteval? Oh shit, I saw that earlier. I don't know what that is. Yep. Should. And you don't want to use it in a context and expect it to evaluate at compile time, and then it doesn't. Make sense? And if anything, if I have a function and its const expression, odds are I probably want it to be used in that context anyway, and I'm probably already going to be using it in that context. Oh, the program? Meaning if you call a compiled or a const expression function with like a standard string or something else that isn't created at compile time, then the program won't work. I'm trying to understand this condition part. Without that condition, the example would contain no set of arguments. Eh? Oh, duh, because if we only return get value, we're only returning non-const expression values, which means that the function is basically not const expression, because it literally cannot execute in contexts that require it to be const expression and evaluate at compile time. If it's less than 0, however, then we're returning a const expression value 0, the literal. So if we call it for less than 0, then it will evaluate at compile time. Otherwise, it will not, and that's why it fails here. So if we passed it foo 0, we'd be golden. Or foo negative something, we'd be good. This pillow's kind of coming in clutch. Maybe not, it's kind of bunching up. Const expression function parameters are not const expression. Yeah, I mean, we saw that before because we literally cannot make them const expression. But the values can be, and the compiler will check the values to see if they are. Because if they aren't, that motherfucker can't be called at compile time, yo. And maybe the reason for that is because a const expression function doesn't have to evaluate at compile time in all contexts. Therefore, if you make the function require const expression parameters, then you would only be able to use the function in a context where it's required to evaluate at compile time. And that seems maybe kind of crazy, so maybe that's why. Curious to see when I made a file really quick. Wow. Oh, it's only 6 months ago. Never mind. My blind blender. It's already been a year and a half. Holy shit. A year and a half into gaming stuff. Yes. Hold on. Yep. And non-const expression arguments or parameters are what make a function not runnable or executable at compile time. Okay. Mic test? Yeah. Wait, really? But if we're returning a const expression value, I don't know what the fuck consteval is yet. So this guy isn't const expression, or isn't always. But in that case earlier with circumference, not Dark and Darker, bro, or not Darkest Dungeon. What the fuck? So this is fine. But in this case, this guy must evaluate at compile time. So if I run this, we can see that it evaluates at compile time because it didn't execute at runtime. But we're using radius here and returning it as a const expression value. So this must be a const expression, right? Or usable within a const expression? I mean, if I made it a non-const expression, like this, it doesn't work because this guy's not a const expression. So it seems like this guy can be used in const expressions sometimes, maybe, but maybe not explicitly. Maybe it's only cool in the return. Oh, it's just because I'm not using radius. Just a warning is an error. Okay. Really? So it's okay to return it because when we're returning, we might be returning it as a non-const expression value. So this guy isn't required to be a const expression. And if he's not required to be a const expression, then we can't use him in a const expression. But in this case, this must return a const expression. It's kind of funky, I'll be honest. Maybe I'm just missing something though. They can't be used in const expressions within the function, but they can be returned as a const expression. Weird. If they are const expression. Guess the compiler will do more work to check during a function call and not during a variable initialization. So consteval versus const expression, I'm curious. It's cool so far. And it's okay in this case. But what about consteval? It's also still okay. Consteval int get thing like this. C is not, so this is fine. It's just that we can't use it within the function. And the problem here is we're using this guy, and this requires B to be const expression, which isn't always the case. But here, goob requires, oh, the problem here is this guy isn't const expression because this doesn't return a constant, therefore this guy can't use this guy because he's not guaranteed to be a const expression. We've already failed here, this part doesn't matter, but okay. But if we have a const expression, for sure, and we call this guy with a const expression, this guy is a const expression. Wait. I think I get 1 hour off. Let's test how the chair feels. Oh no. Oh, this is shit. That's not too bad. So it's fine. Oh, hold on. I'll go till this is 8:30. So here, this guy's const expression. We're calling foo with a. This guy in this case is const expression, therefore he can be used in a const expression. So the point here. I'm gonna have to reevaluate this. Okay. To be continued.